Hi there, I'm Scott Lowe with ActualTech Media, and we're here today with Jeff Sosa, who is the head of products for Pavilion Data. Jeff, thank you for having us in your offices today.
Thanks for coming.
So we're going to talk about what Pavilion Data brings to the world. So what are you doing? What's the problem that you're trying to solve?
So I have a picture up here that'll help explain that. We're focused on solving problems that are encountered in these scale-out environments where you have what we call rack scale applications that run across clusters of servers, and they use locally attached SSDs in all the servers. And this creates several problems when you're not sharing storage. So here, I list them on the bottom here. So one is poor utilization, right? So for example, you got a lot of stranded capacity typically. You're probably overbuying storage for these systems.
Common problem today. Yeah.
Right. So it's very underutilized. We find maybe under 50%, under 30% in a lot of cases. So you're spending a lot of money on flash you're not using. If you try to right size, it's usually a one-size-fits-all kind of config in this situation. But if you decide you need more compute or you need more storage in specific areas, you end up creating more SKUs in your environment, which is problematic because this just isn't flexible, right? Also, unpredictable performance. These apps are dealing with storage management as well on these servers, and so that creates unpredictable application performance a lot of times. Also, they're moving data all over the place. They're doing a lot of their own data management. And then also, you have issues with security, backup, and compliance. It's not easy to take a copy of all of this for backup, right? So these are the problems we're trying to attack with our product, the Pavilion Data all-flash array.
A lot of it's a consistency problem. As soon as you go to silos or islands or whatever the phrase you want to use is, you have these common problems across the spectrum. What is Pavilion doing to address all the problems you just told us about?
So we've built a shared storage array that uses NVMe technology end-to-end, all the way from the application hosts down into the server, and allows you now to bring the benefits of shared storage to these environments that haven't been able to enjoy those benefits up till now. And there's specific reasons. It's because there hasn't been a shared storage product that can deliver the amount of performance you need to actually replace the local SSDs in these clusters. So we're the first product that can actually do that and help you solve all these problems.
NVMe is going to be revolutionary as it continues to penetrate the market.
Yeah.
And you're bringing the fabric goodness to the world, right?
Yes. So what it's allowing us to do is two things. You obviously have the very fast, low latency media that we use exclusively in our product, but you also have networking protocols now, storage protocols that run NVMe protocol that give you low latency even across a network now. So that's what I mean when I say we do NVMe end-to-end. So from the application running in the host all the way to the media in our box, it's all NVMe all the way.
So previously, you were having to do all kinds of translations to different places, either to Fiber Channel or to iSCSI or to something, to NFS or to whatever. And you had to deal with the inherent limitations of things like SAS and SATA at some point as well. NVMe obviously strips away all those limitations, and you get these huge highways with lots of lanes.
You got it.
And you're leveraging that in your platform.
That's right. It allows for a lot of parallelism. And you think about it. These kind of apps, they're trying to achieve parallelism by distributing themselves across a lot of different compute and individual servers. And NVMe fits very well with this environment because that parallelism now can go all the way from this whole set of servers down to the shared storage appliance by using the protocol end-to-end.
Rather than having some single point of failure sitting in the middle that's trying to marry the parallelism together.
Or inefficiently trying to map a serial protocol to NVMe on the back, which isn't going to deliver the benefits that we can deliver by going end-to-end with NVMe.
So what's it look like?
Oh, I have a picture.
I thought you might.
So this is the back of the array, and it has what we call, it's designed a lot more like a network switch than a storage platform, it turns out. So we took a lot of design characteristics of director network switches in the design of and used it in the design of this. So what you see back here are what we call I/O line cards. You have up to 10 of them. Each of them has 4 100 gigabit Ethernet, RDMA capable Ethernet ports. Okay? So this is what gives you the bandwidth you need to feed all those servers in a rack or multiple racks, right? From a single appliance. You need to provide a lot of bandwidth. So we do that. Each of these has 2 storage controllers on it, so we have up to 20 storage controllers in the array. So that's the other thing that's very unique about what we've done. So we've added all this storage processing horsepower in a single 4U appliance, right? That allows you to replace a whole rack worth of SSDs, local SSDs, and not suffer any performance degradations.
Another interesting thing that you told me about your architecture was that the management capabilities don't get in the way. I mean, they don't get in the data path. They basically configure the blades and then get out of the way.
Yeah, so all the control plane operations, we call them, go through these two redundant management cards. And all the I/O goes straight into these ports here where the storage controllers exist, right? So once you provision something, you're serving off of one of these controllers along with the associated ports. But yeah, the management cards are out of the way at that point. They only do control plane.
So you've really taken a software-defined networking paradigm and married it with your storage array.
Yep. Yeah, and if you think about it, what we've built here is essentially a cluster of 20 independent computers.
Yeah.
All in a single chassis, all in parallel processing
top-of-rack
storage.
management.
There you go.
Yeah.
Yeah, exactly.
So do you have another view we can show us? Because I think you have a more complete look at the cluster.
Yeah, so here's the top of the product. This is the top of the chassis looking down with the cover off. Here's those I/O line cards I talked about where they had the ports on the back. Each of these, again, has two independent storage controllers, so you have up to 20 controllers in a single array. And then here's where we have all the NVMe SSDs. So there's up to 72 in a single 4U appliance, right? Allows us to get up to a petabyte of capacity in a single 4U appliance. And we do RAID 6 dual parity RAID across up to 18 drives, which prevents from up to 2 drive failures in a single RAID group or 4 for the whole chassis.
And when you start talking about SSD and NVMe, I/O penalties start to go away as an issue. So RAID 6 is a great way to provide that dual redundancy that you wouldn't want to do with disk because it would wreck performance. It doesn't do that in this platform.
Yeah, and it allows customers in those rack scale applications maybe to not make as many copies of data around for data protection purposes, right? So now we have resiliency built into the appliance. We can take all that off of those servers and off of the network and just process all that here centrally. One other thing I wanted to point out is that we connect the 20 storage controllers to the 72 SSDs in this drive array, the NVMe SSDs, through very high-speed PCIe fabric that's internal to the system.
So you mentioned that this can hold 72 terabytes in a single 4U?
72 drives,
72
up
drives.
to 920 terabytes with the current drive densities that are on the market.
In a single 4U chassis?
Single 4U chassis.
So I need to go beyond that capacity. How do these connect together to grow beyond, to scale?
So what we're finding is, given that we have so much compute and storage processing horsepower in the single box, what we're finding is that it's almost too much for a lot of customers. So what they do is they start with a smaller number of these line cards. So for example, they're very modular, and you may decide, look, for my workload and bandwidth needs, at least to start, I only need maybe 8 network ports and a couple storage or 4 storage controllers. So you could partially populate the box.
Okay.
So you can scale within the system. And that's what most people have wanted to do. They usually start with a few line cards and then they'll add more as they need, as well as with SSDs. So you can add these as you need them. You can start with 18, add 18 more, add 18 more, add 18 more over time as you need to. So you can scale out within the system.
Very good.
Yeah.
Thank you for this overview of your architecture.
Yeah, thank you very much.
And thank you to our audience for watching this Roadcast video.